Hey y'all, today we're going to do the notes on homeostasis, and the first thing we're going to do is go over just a little bit of history. So back in the day, 1859 or so, Claude Bernard thought that there must be something going on in the body that helps maintain a stable environment, or there has to be something going on in the body so that as we play the balancing act of even temperature change, for example, that if we go outside and it's hot, we don't get as hot as it is outside. Or in the reverse, if we go outside and it's cold, what is our body doing to keep us at a stable internal environment or a stable body temperature? And then in 1930, Walter Cannon used Claude Bernard's research and said, well, let me keep going with this. And he figured out that there is something going on, and the various mechanisms of that are still being discovered, but he put a term to it and said that this is homeostasis. This is the same, or this is something that the body does to stand still or to maintain a stable internal environment despite all the changes that are going on externally and internally. And what we'll go through now are the mechanisms that happen in your body, or the processes that happen in your body that help to maintain this stable internal environment or get us back to the idea of homeostasis. First, we'll look at a flow chart of the mechanisms that are, or the parts of the mechanisms that will help us maintain homeostasis. So what are the components? What are the pieces and parts of our body that are pretty consistent and that are pretty cut and dry for how do we get homeostasis to happen? And the first one is a stimulus. There has to be a signal. There has to be a stress. There has to be a trigger for homeostasis to need to happen. And that stimulus is detected by a receptor. It can be detected by a receptor in your skin. It can be detected by a receptor that might be buried within an organ. It has to be detected by something. There has to be a way to ping the reaction. Almost think of it like a GPS. And I'm driving through town following a map. It's constantly pinging where my car is. The ping there, or the receptor, is picking up the stimulus. The stimulus is, where is your car? The receptor is my phone. They're saying, oh, you're right here. Oh, you're right here. Oh, you're down the road. And so the stimulus is detected by a receptor, and then it's going to send a message called an afferent message, AFF, afferent message, towards the control center. And that control center is your brain or your spinal cord. Remember, back to organ system, that's the only area of the body that can really interpret and integrate information. The afferent message is going towards the brain or spinal cord. It is detected by the receptor, and the receptor sends it to the brain or spinal cord. The stem AF means towards. The control center will then decide, okay, what do we want to do about this? And instead of it sending an afferent message, it's going to send an efferent message. And that efferent message is going to go to an effector. And in the body, effectors are only muscles or glands. So the only things that can get told what to do, or the only organs that the brain can interact with and say, do something or don't do something, is a muscle or a gland. Okay, and a gland is going to make something. A gland is going to make sweat. A gland is going to make oil. A gland is going to make a hormone. A muscle is going to contract, or it's not going to contract. It just depends on what the brain is sending. What is that efferent message? Is the efferent message to speed up, to slow down, to do something, to not to do something? And that effector, depending on its response, is going to cause an effect. And that is either going to be a negative reaction or a positive reaction, or negative feedback or positive feedback. 98% of the mechanisms in your body are negative feedback, or they are negatively controlled. But the remaining 2% are positive feedback, which we'll look at. Okay, the types of feedback are, like I said, negative and positive feedback. And what is that? That is, or what is negative feedback? The key to this idea is that it lessens the intensity of the stimulus. Okay, so you got to always go back and think, well, what was the stimulus? If the stimulus was an increase in temperature, if we are lessening the intensity of that, we are bringing temperature down. If the intensity was an increase in blood sugar, we don't want it to continue to increase, and so we decrease the level of blood sugar by a negatively controlled feedback mechanism. All right, let's look at an example in the body. If a stimulus is cold temperature, we walk outside, it's cold. That's all the stimulus is. It is a change in some kind of environmental thing, change in some kind of internal environment issue or external environment issue. That stimulus is always detected by a receptor. This time it is temperature receptors in the skin. The receptor picks up that stimulus and says, oh, okay, it's cold. It then sends an afferent message. Okay, so this right here is an afferent message towards the brain or spinal cord. That brain or spinal cord is classified as the control center of your body. So we send an afferent message to the brain, specifically an area of your brain called the hypothalamus. Okay, right now don't stress too much about that part of it. Just know that the afferent message goes to the brain, and later on we'll learn all of those parts of the brain. We are then going to send 3 efferent messages. If it is exiting the brain, or it is going from the control center to an effector, it is going to be an efferent message. That efferent message sends a message to one effector called the erector pili muscle. Notice that this is a muscle here. The only 2 effectors in the body are muscles or glands. We send an efferent message to the erector pili muscle. We also send an erector pili or efferent message to the skeletal muscles of the body. The last one are the smooth muscles of the walls of your blood vessels. Big idea here, we're sending an efferent message to an effector. Effectors are only muscles or glands. In response to that efferent message, your erector pili muscles are going to contract, and they're going to cause goosebumps. Okay, goosebumps are nothing more than a contraction of an erector pili muscle, and that little bump that you see on your skin is where that muscle has gotten bigger. Okay, I contract my bicep, it gets bigger. Well, erector pili muscles is the same thing. If it contracts, it makes a little bump on my skin. That'll also pull the hair up on your body. It makes the hair, originally the hair was laying down and the hair stands up. That traps a layer of heat against your skin. Is it super efficient? No, not really for us, but a polar bear, it's really efficient. They have thicker hair. They have a lot more fur than we do. Skeletal muscles are also going to contract, and that's going to cause shivering. Okay, shivering generates body heat. Muscle contractions generate heat. A lot or a little, it just depends. I mean, you just shiver a little bit, that is a involuntary contraction or a contraction that you don't control of a skeletal muscle, and it will generate heat. Finally, you will vasoconstrict. And what that means is the diameter of the blood vessel gets smaller. And if we squeeze on that blood and we restrict the blood flow in your body or restrict the blood flow of the blood in your skin, that kind of keeps the heat where it is. It reserves that heat in your body and helps to raise body temperature. Now, it does require all 3 of these to help bring your body temperature back up. Remember, if it is negative feedback, we decrease the intensity of the stimulus. Well, if I'm decreasing the cold temperature, I am going to bring the body temperature back up. And once it reaches normal, once I get back to 98.6, we shut off the stimulus. We shut off the process. Okay, negative feedback is more than just cutting it off. Well, we got to get it back to the normal range, back to where it needs to be, and the initial stimulus is stopped. If we continue and we continue and we continue to do these responses, then body temperature would get above normal. Okay, so the goal is to get us back to normal, back to homeostasis, and the stimulus will turn off. In positive feedback, we've only got two main examples. Well, I say positive feedback is 2% and two things you need to know: babies and blood. Okay, when babies are being born, it's positive feedback, and when blood is clotting, it's positive feedback. Okay, in positive feedback, instead of decreasing the initial stimulus, we are going to speed it up, and we're going to increase the initial stimulus. Okay, let's look at a picture here. Mom's pregnant. She's close to delivering. Baby is oriented head down. Okay, which means that the baby's head is down and it is putting pressure on the cervix. Okay, the cervix is just the end of the uterus. As the baby puts pressure on that cervix, the stimulus is pressure. It is detected by a receptor called the pressoreceptors. Okay, makes sense. Pressure receptors. That receptor is going to send an afferent message to the brain or spinal cord. It then travels through parts of the brain to a gland, and it sends a message to the posterior pituitary gland that says, hey, give me some hormone, give me some oxytocin. Oxytocin is released into the bloodstream. That sends a message to the uterus. The uterus will then contract. Okay, so really you've got two effectors here. You've got a gland, which is the pituitary gland, and you've got a muscle. You've got the smooth muscle of the uterus. The uterus contracts. When it contracts, it squeezes on baby. Baby pushes down into the cervix. That then increases the pressure on the cervix. Well, that's the stimulus. I have increased pressure. I have increased the intensity of the initial stimulus. It squeezes on the pressoreceptors in the cervix, sends an afferent message to the brain. Pituitary gland says, here's some more oxytocin, which then says, here's some more pressure, here's some more squeezing, here's some more contraction, which then increases pressure, which then sends more afferent messages. So it is this cyclic pattern of more and more and more and more. Instead of decreasing or shutting off the initial stimulus, you are increasing it. Okay, so stimulus is baby's head. Okay, baby's head moves into the birth canal. That puts pressure on the receptors in the cervix. That sends an afferent message to your brain, to your hypothalamus, to your pituitary gland, which then sends a message to the uterus by the release of oxytocin that says, contract stronger, contract stronger. Let's amplify. Let's make the initial stimulus stronger until eventually baby is born. Okay, once baby is born, no pressure, no afferent message, no message to the hypothalamus, not to the pituitary gland, not to the uterus, and the process is negative at that point. But during labor and during the contractions, it is an example of positive feedback. All right, now, again, what happens if this goes wrong? What happens if this does not work? Okay, another name for disease is just a homeostatic imbalance. What if I cannot maintain my blood sugar levels? What if I cannot make insulin? What if I'm trying really hard to make insulin, but I can't make enough? You end up with diabetes. Blood sugar maintenance is an example of a homeostatic mechanism in your body. Well, we know plenty of examples of diabetes. How does that arise? Okay, could you be born with it and have type 1 diabetes? Could you develop it over time and have type 2 diabetes? Another example would be hypothermia. Hypo means under, therm is temperature. Well, what if you can't get back up to normal? What if you're in such a cold environment that no matter what your body does, you can't get back to 98.6? Then you end up with hypothermia. High blood pressure is another one. You're trying really hard to relax those walls of the blood vessels. But if you can't, due to disease, due to vascular or vessel disease, due to heart disease, then you can end up with high blood pressure. Okay, so many of the diseases that you think about may not be things that you catch, like strep throat or mono or whatever. They are a result of a homeostatic imbalance within your body.